Section 12.1 concerns three-dimensional figures. So from this point on in geometry, we're going to be talking about three-dimensional figures. It first talks in 12.1 about orthogonal drawings. Basically, it's a two-dimensional drawing of a three-dimensional figure from various perspectives. You're not going to be responsible for this information, but I do encourage you to read through example 1 on page 636 and 637. So, a polyhedron, which is, the definition is a solid with all flat surfaces that enclose a single region of space. Each of the flat surfaces or faces is a polygon. Remember, a polygon is made up of line segments that don't cross over on itself and they're closed. A line segment where the faces intersect are called edges, and the edges intersect at a point called a vertex. So each of those bold things are important. So this right here is what we call a triangular prism. The base here is a triangle, so that's where the triangular comes from. So if I was to ask you to name the faces of this triangular prism, you would have rectangle A, B, D, E. You would have rectangle A, B, C, F. So this is here and here, the front and the back. You would have on the bottom, you would have E, F, C, D. And then you have two triangles, so you have B, triangle B, C, D, and you have triangle A, F, E. So those would be the faces, or all the sides of that triangular prism. Then the edges are going to be all your lines. So edges would be AB, BC, CD, ED, EA, and then you have AF, you have FC, and EF. I think that's all of them. So that should account for all of them. Okay, then you have vertices. Now the vertices, or the vertex, is basically your point. So it's all your letters. A, B, C, D, E, and F. So that would be naming all the faces, edges, and the vertices. The vertex is the singular term. We'll go ahead and change that to vertices of this triangular prism. A rectangular prism means the base is a rectangle. Okay? Now if I needed to name the faces of this, you have the top, which is A, B, C, D. You have the bottom, which is G, H, E, F. You have this end. Okay, so I have D, C, E, F. You have that end, which is A, B, H, G. And then you have the two flat surfaces, the front and the back, if you will, A, D, F, G, and B, H, E, C. Okay, if I wanted you to name the edges, those are all your straight lines. So AB, BC, CD, DA. Okay, that's the top. And then the bottom you have GH, HE, EF, and FG. And then up and down you have DF, you have CE, you have BH, and you have AG. And then if you wanted to name the vertices, you have all the letters A, B, C, D, E, F, G, H. Okay, so you have to be able to do that with each one of these. This is what we call a pentagonal prism because the base of it is a pentagon. So again, and I'm not going to take the time to do this, but you'll be able to name the faces, the edges, and the vertices, and name that as a pentagonal prism. Now a pyramid is a little bit different. It's a polyhedron where all the faces intersect at one vertex except for one. So this is a triangular prism. It kind of looks like this. I don't know if that makes it easier or harder to see it, but all the sides are made up of triangles. They come together at one point. So it has one vertex, and it would have 4 faces. So each of the triangles on the side and the base, okay? And of course, so all of these would be vertexes, and then all of these would be faces. If your base is a pentagon, then it's called a pentagonal pyramid, and you also have to be able to name the faces, the edges, and the vertices on those. Other three-dimensional figures that we're going to talk about, you've got a cylinder that has congruent circular bases, top and bottom, and parallel planes. So that green circle is parallel to the blue circle. So it has bases, but it doesn't have faces, edges, or vertices because it's not made up of polygons, okay? So this one would have a base of A and a base, and actually we probably need to put the circle symbol there. So the base is circle A and circle B. Okay, this is a cone. A cone has a circular base and one vertex. So there's no faces and no edges. Because remember, the face has to do with it being a polygon. This is not a polygon. It's not made up of line segments. So the base here is circle B, and the vertex is C. A sphere is a set of points in space that are all equal distance from a given point. There's no vertices, no edges, no faces, and no bases. In other words, this is a ball, okay? Because there's no polygons, there's no points, so therefore, no vertices, no edges, no faces, or no bases. All right, your homework is on page 640, 16 through 21 all. Make sure you read that information and regurgitate what they're asking you to give. Again, if it says anything about an orthogonal drawing, you do not need to do it.